Okay, students, so today we are going to look at exponential growth and decay. Sorry. So this objective is we are going to see exponential growth. And we see exponential growth and decay in nature and in science. So this is one way that we can see the mathematics relate to science. And we're also going to graph these and become familiar with this word, asymptotes. Okay, so write this down in your notes. We have exponential growth, and the function involves expressions of y is equal to a times b over x. So y is equal to a times b raised to the x. So this is what makes the exponential functions. Is now we have our variable, our independent variable. So let's put that. This is our independent variable as an exponent. And here's our dependent variable. And that's my y value. I could have also put f of x here as well. So this is equivalent. F of x is equal to a b raised to the x. Okay, so b, we're going to call that the base, and the exponent is x. My a value, now if I have a is greater than 0, so if my a value is greater than 0 and b is greater than 1, then the function is exponential growth. It is an exponential growth function. And let's define this, so put this in your notes. The asymptote is a line that the graph approaches as you move away from the origin. So as we get further and further away from the origin, it approaches the asymptote. And for this one, for y is equal to a b to the x, the asymptote is always going to be, so it will always be the x-axis, or y is equal to 0 for this case. So for this case, we always have a y is equal to 0 asymptote. Okay, so let's look at an example here. All right, for this objective, we want to graph the function. So here's my function. So let's graph this. So the first thing, draw an XY table and find 2 points. So let's make our graph and do an XY table. Now I chose 0 and 1 here because they're easy to solve for what my y variable would be. Well, if I plug in 0 for my x, that makes it really easy because anything to the 0 power is 1, so my answer is 2/3. And if I plug in 1 here, well then 1, that becomes 2, so 2 times 2/3, and that's equal to 4/3. Alright, so now let's come in and graph these. So there's 1 point, and there's 2 points. And when I connect those, I see my graph, and I'm connecting it with a line that gets bigger and bigger and bigger. So I'm just following this exponential curve. And I know that my asymptote, remember my asymptote is y is equal to 0. So let's draw that in as a dotted line. My x-axis is my asymptote. So that means that this function gets closer and closer and closer to the axis. It looks like it touches here, but it actually never touches. It just gets closer and closer. So this is my graph. This is exponential growth. So examples of exponential growth is you could say like this could be population growth. And this, on this axis we could have years. This could be CO2 level in our atmosphere. We can have many things follow exponential growth. Bacteria reproducing. There's a lot of examples of this. Okay, let's graph this one. Now the first thing we should see, is it exponential growth? Now remember, for exponential growth, we had to have our A value greater than 0. A value had to be greater than 0. Could not be negative. So in this case, this is not growth. This is neither. But let's graph it anyways. So when I graph it, I'm going to do the same thing. I'm going to find 2 points. So I have 0 and 1. Those are easy points to find. And when x is 0, this whole thing becomes 1. So that's -2. When x is 1, I get -4. And if I graph that, I get this function here, which is not exponential growth. This is not a growth function. But my asymptote is still this x-axis, or y is equal to 0. Okay, so now let's graph a function that that has a k value and an h value. So remember from quadratics, our k value and our h value just shift the function. So we're going to begin by graphing just the base function, which we call sometimes the mother function. So we're going to graph this mother function, and then we're going to translate it. So we're going to translate it h units, and remember the h and the k value, the h units go left and right. So if it's negative, it goes left, positive, right. K units, negative is down, positive is up. Let's look at this. Let's graph this function. So the first step, let's graph the mother function, the base function. We're going to graph this one. We'll do it in a dotted line. So we're going to pick 2 points. Plug in 0. If I plug in 0 here, I get 2. If I plug in 1 here, 3 to the first power is 3 times 2 is 6. So I'm going to graph that, and let's graph it. Let's put a dotted function, and remember that my original asymptote is y is equal to 0. But now I have to shift this. So I'm going to shift this by my h and my k values. So let's move this, or translate this, using our h and our k. And we have to see, like, oh, if I look up here in my base formula, my h value, since it's x minus h, that means that h is a positive 2. Positive 2. And it's plus k, so that means since this is plus k, that means k is a positive 1. So when we shift this, our h value is going to go 2 to the right, and my k value 1 up, because they're both positive. So I'll shift the other point, 2 to the right, 1 up. And now I'm going to redraw my graph, and notice that my new asymptote has shifted up. My asymptote is shifted up, and it is shifted up exactly what your k value is. So this is my new asymptote. So my asymptote, well, in this case, it's y is equal to 1, because that's my k value. But we can think the general rule here is that my asymptote will be at my y is equal to whatever my k value is. In this case it was 1, but my y is going to be equal to k for my asymptote. And remember that the definition of asymptote, that this function gets closer and closer to that value, but it never touches it. never reach that. And this is a growth function. Alright, let's look at exponential decay now. So here's exponential decay function. We still have the exponential equation, but now you'll see that again a is greater than 0, that's the same, but now our b value has to be, let's put in parentheses, it has to be a fraction between 0 and 1. Has to be a fraction between 0 and 1, or a decimal between 0 and 1. So growth, a is positive for both of those, so these are the same. A is positive for both of those. But for this one's a fraction between 0 and 1, and this one's greater than 1. Okay, let's look at this. So tell if it is exponential growth, decay, or neither. So in this case, let's say my a value is equal to 4, my b value is equal to 1/2. Well, b is a fraction between 0 and 1, a is positive, so that gives me decay. That gives me decay. And you can kind of think of what decay looks like. You start off with something really high and you're getting closer and closer to 0, it's decaying. So this is decay. And this is not an accurate graph, it's just showing a graph of decay. Alright, the next one. Well, let's say my a value is equal to 3, so that's positive. B is equal to 3/2. Well, that means that b is greater than 1, so therefore what do we have? We have growth. Growth function means that things are getting bigger and bigger. Again, this is not an accurate graph, it's just showing a basic growth. Now the last one, here I have a is equal to -2, so right there a is not positive, so therefore it's neither. So we have neither. And if we look at this one, we could say, oh, it would have been decay. Would have been something like this. However, it's got that negative which inverts it, so this is what the actual graph looks like. Something like that. And it's not, this is just a basic approximation, because that negative inverts it. Okay, so let's graph a couple of these. Whoops. There we go. Okay, so let's graph the function. First thing, draw an XY box and create my graph. So I have 0 and 1, and when I plug that in, I get 4 and 8/5. Plot those points, and again, notice that my asymptote is y is equal to 0. So my asymptote is y is equal to 0. And this is decay. Okay, the next one. Same thing. Make my XY table. When I plug in 0, I get -2. Plug in 1, I get -2/3. And this one, this is a neither. It's not growth or decay. Alright, because it's growing but it's on the negative, so this is, we don't call this exponential growth or decay. Alright, just like the last one, let's do one where we have to shift. Now remember, our asymptote will be at y is equal to k. So let's come down here, and the first step, let's graph the mother function. So with the mother function, we take off the h and we take off the k. So here's my mother function, and let's pick two easy numbers, 0 and 1. When it's 0, that's 1. 1 times 5 is 5. When it's 1, it's 5 times 1/8, which is 5/8. Graph that, and we're going to go dotted line because this is just our mother function. Now we need to shift it. So then move h units. So let's come up with Well, what's my h and what's my k? Well, my h is a negative 2. So because the original equation has x minus h, in order to get that to be positive, I would have to plug in a negative 2 there to get that whole thing to be positive, because you need two negatives. So that's why h is negative. And then k, well, since it's a positive there, I would have to plug in, again, a negative 2 in order to get a positive. So that's why that's my k. So this shifts left 2 units, and this shifts down 2 units. So let's look at that. Down 2 units, left 2 units, down 2 units. And before I even draw this, let's shift the asymptote as well. So it goes from 0, and now our asymptote is going to be at y is equal to my k value. It's going to shift down 2 units. So my new asymptote is y is equal to negative 2. And let's look at what happens when we graph this. We get our new function just shifted. Okay, so that is how to graph decay. So we have growth and decay. We'll look at it in class, and we'll talk about together examples of where growth and decay are exhibited in nature. And we'll watch some YouTube videos about that.